Hey guys, welcome back to Algos Made Simple. Today we got a little bit of a trickier one for you depending on how familiar you are with binary trees and how comfortable you are with classes. But we're going to make it as simple as possible and give ourselves something that we can really reach back for if we see this problem in an interview, something that's easy to recall. So let's dive right into it. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So I would let the interviewer know, okay, I understand I'm getting a binary tree, and I basically just want to see what the longest path is from that top root node to the very last child node or leaf node, how many levels that is down. So kind of easy to understand conceptually. Let's look at the example. You have your root node 3 here, and of course you're at level 1, level 2, level 3, so 327. It's going to be 3 is going to be your longest path from the root node down to the farthest leaf node. And again, you can see that with 3, 20, and 15. If you went 3, 9, you still got to get over here 20. So you're gonna, immediately, hey, if you've been knowing these problems for a second, you're gonna do either depth first search or breadth first search. And in this case, either of them work here. So if you're not familiar with those, you need to kind of do a little research on that. But getting in here, the first thing that might kind of throw you a little bit is the input here. So this input is just an array, root 3, 9, 20, null, null, 15, 7. But if you look at what they give us here, it's going to be in the class tree node. And what's going to happen is you're going to have the following properties. You're going to have a value property, and which would give you that 3, a left property, which in this case would give you that 9, and a right property, which would give you that 20, essentially. So you've got those properties to work with. So anytime they give you something like that, you know you're probably going to utilize it. So with that being said, let's get our game plan going here. I think the simplest way to do this one, although you could do it with recursive DFS or iterative DFS, the simplest way, in my opinion, is to use breadth first search on this one, just because it's level by level. Breadth first search is good for level by level. And with breadth first search, you're going to utilize a queue, so we can go ahead and put that in here. And again, I would recommend doing this in an interview setting. That way, one, you don't forget about the queue, you have it chief of mind, and you've already got kind of an outline of what you're going to be working with here, but it also lets them know, okay, he knows he needs a queue on this one, he knows a queue is associated with breadth first search. You're just kind of building the groundwork to kind of show that you understand code and you've been doing it kind of thing, and just to keep you on track at least, if nothing else. So going from there, you got breadth first search, queue. We know we're going to need a level variable to keep track of what level we're on as we're running the breadth first search. So that's really the main core of this problem right here. So we would go in and you'd have depth, max depth, and you pass through the root, which of course pass through with it, having all these properties, but we're just going to kind of simplify it here. And we would say the very first thing you want to do is make sure this root has some depth to it. If it doesn't, then we're getting off pretty easy here. So if not root, then you can just return 0. So that's if we had an empty root there. All right, and then of course we said we needed a level variable. So let's go ahead and start off initializing that to 0. So we're at level 0 there. And then we know we want to set up a queue. There's a couple different ways you could do this. You could do the dequeue and all that kind of stuff and utilize what comes with the language here. But to make it very, very simple, let's set the queue equal to an empty list. And inside that empty list, we're going to put root in there. So the root that we're passing through here. So then you know, okay, I've got my level, I've got my queue, I know I need to do breadth first search. What is going to be my trigger for these loops? And the obvious thing that stands out here is going to be the length. While there's something in this queue is why if you've done breadth first search for a second, you know while there's something in the queue, you want to keep going. Same way with depth first search, while there's something in the stack, you want to keep going. So that's what your fuel is. The fuel is having something still remaining in the queue. So we'll go here and say while queue, and again all that means is there's something in the queue. And the next thing we'll do, because we want to get all these items off the queue or append the items we need to append to it, but the initial items we want to get them off the queue. So I would do a for loop. Again, 99.9% of these problems have a for loop, so if you haven't used one yet, you might want to think about it when you're doing the problem. You're thinking, okay, there's probably a for loop involved here. So you do something like for I in range length of Q, and that's going to give us what that Q is right there. So in that given point in time, everything that's on that Q right there is what we're going through in the for loop. So even though we might be removing stuff, whatever, it's not affecting this particular Q. It is going to affect whether we stay in this while loop or not. So we go there. And the next thing you know you need, okay, we got to get something off of our Q. We're utilizing the Q. That's where our head's at. So let's call it node, just because that goes along with the tree language. You could really call it anything you wanted to, and do Q.pop, and we want to take it from the immediate left, the very first thing on there. So we got node equals Q.pop at index 0, and again that'll give us that first one. And then we will go, so this is going to be first in, first out. And what we'll do from there is, you've got your node, if, and of course this is where your properties, you see these properties, this is another thing we should put in the game plan here. You know there are properties. So they wouldn't probably give you these properties unless you're going to utilize them. So with that being said, we've got our node that we're working with here. And if node.left, so if this node is not null, so the property on the left, so whatever's to the left of it, so like in this case 3 with the 9 and 20, these are not null, but 9's left would be null, and 9's right would be null, and 15's left and 15's right, and 7's left and 7's right would all be null. But if it's not, then what we want to do here is, we know there's another level to go on, so we want to do Q.append node.left, because that's going to keep us in this loop, which is going to give us a chance to bump this level up again. So we got Q.append node.left. Here's a little page break. I'm gonna go up here and delete this just to keep us on the same page here. And we don't need that example anymore. Okay. So Q.append node left, and then of course you're gonna do the same thing for the right, if node.right. So again, that's just saying if that right property is not null, if there's something to the right of this one, then we want to append it, and we're appending those in the same loop. So that means we won't get an extra level out of this one or whatever. These are on the same level, so it's just one level. So then all we have to do, we've gone through the for loop and we get out of it, we need to bump this level up one. And then what you put in this Q is going to allow us, as long as it's not null, well, you won't be putting a null because you're checking it. But anyway, if this Q has something in it, we're going to come back in here and that'll be another level. So while we still have something in this Q, we will keep bumping the level up. You eventually will get to where you don't have anything in the Q, because when you come down here, node.left will be null, node.right will be null. We won't add anything to Q. We'll have gone through this hole for I in range Q and popped off every single node and checked it out, and we won't have anything left. So once that happens and we get outside this while loop, we'll just want to return level. And again, this should work really, really well. I think we got everything correct here. So what you would do to test it, you could just look at that original, node that we deleted or whatever, but you had the 3 with the 9 to the side and 20 to the side, and you come down here and see that node, you put all that, the whole entire root in the queue, and you come down here and the whole thing, you would go, okay, popped off the 3, to the left of it, it had a 9, to the right of it had a 20, and those would go into your queue. And you would come back to the next thing, and it would pop the neighbors off of the 9 and the 20, etc., etc., and you keep popping neighbors off, and again you would go through the whole queue until you reach these they're going to be null. So then at that point the queue would run dry, we would be adding nothing to it, and then you're just going to return level at the end. So again, I think this is the simplest way to do this one. There's different ways to do it recursively or iteratively, but I think the breadth first search is the most hands-on, easiest one to get some good going. Like, it's pretty self-explanatory that you know you're going to have to take that root that you're getting in and do something with it. Well, let's put it in a queue. you know you're going to need to keep track of the levels because you're trying to figure out how far the depth is. So, okay, we need a level variable. Okay, we know we've got the queue. We know that's what's going to be our loop's going to be based off of. So while there's something in the queue, we're going to keep rolling. And then you know, okay, we got to get all this stuff off the queue, and then the neighbors that we want to put back on the queue so we stay here and go to the next level. So it's really kind of the whole problem in a lot of BFS, DFS, if you'll kind of stay in the problem, it all builds off of each other. So if you get stuck, just think, okay, have I used this queue to its full potential yet? Have I made a loop based off of it? Have I made perhaps another loop based off of it that could come into handy? And then finally, have I taken stuff off the queue and put stuff back on the queue? That's common practice what you're going to be doing with these. So again, this runs in O of N right here. So a really good solution. This would be one that I think would be a nice one to get an interview and something that we can definitely knock out of the park, guys, and a nice little tree problem. If you need to, if you're not familiar with the classes, with properties and stuff like that, that's something to brush up on. And if you're not familiar with trees in general, definitely look into it. But it's not as scary as you would initially think that a binary tree and these kind of tree problems are. They're not as easy and intuitive as array problems are, at least in the beginning, but they're nothing to be scared of. So anyway, thanks for watching, guys. We'll keep grinding and see if we can get some more videos up.